right, now let's move on to the operations. Now, these are the types of data that we can deal with. Now, what kind of operations we can apply, and then depending on the type, okay, we have to specify the type, the operation based on the type. So numeric type obviously have arithmetic operations, right? So arithmetic operation like subtract and add and multiplier, which you're familiar with, plus, minus, and star. Are you familiar with the double star? So what does it mean? What does the double star mean? Yeah. The power up. Power up, yes, the power. Okay. So if I say If I say 2 times 3, that's just multiplication, right? So it should be 6. 2 double stars 3. This is 2 to the power of 3. All right? So that's an 8. Okay. The division also you are familiar with. Okay. So the division divides 2 numbers, and then the results can be a float, even if the operands are integers, the results can be a fraction, right? So that's the true division. Now, if you want to eliminate the fractions, you can use this lower division. So if you're dividing int by int, and you want to eliminate the fraction, you just want you want it to be lower, you can use the double slash. Now, the modulo is just the remainder of the operation. Okay, the remainder. All right. So the simple division. Now, this is slightly different than what you know from Java. If you are in Java, if you're dividing int by int, the result is not float. The result is int. It is automatically floored. All right. But here, the true division just gives you the actual result, even if it's a fraction. So let's say I want to divide 5. True division by 2. So that's a 2.5, right? Now, if I floor it, it will truncate the fractional part. Now, if I want a remainder of the division, then I can use the modulo, which is the ampersand. Okay. All right, so now the type that comes out of the true division is float. The type that comes from the modulo is int, and the type that comes out of the flooring is int. Now, I often use this flooring with int by int. So someone last year they tried it with float over a float. It only truncated one decimal number. So it didn't end up being int. So it seems it just like it floors one level. It doesn't go to the discrete number right away. Now for the Boolean, there are 2 types of operations related to Boolean types. There are the logical operations or logical operators. Well, normally they will apply on any type, like in other types, usually arithmetic. Okay, so at least a comparison one. So I should do a comparison here, sorry. These are comparison operators. So comparison operators usually apply in other types, but the result is Boolean. But usually this greater than less than usually are related to arithmetic values. But the results, how are they related to Boolean? Is the result. We should expect a true or false out of the application of these operations. The logical operators are like, the truth value, the truth table, the truth table. There is an or, an and not. So that's pretty much it. It's just the difference here, not the same symbols that are used in Java. So in Java, for the and, we use 2 ampersand, right? Here we just write the word and. The or in Java is the 2 bars. Here just the actual word or. Now the not, when we're using the negation by itself, then it's not, then OT the word. But if you're using the negation with the equality, then it's the exclamation mark. Okay? Now here's the thing, it's a little bit tricky. We should expect that the logical operations or logical operators to apply on logical values, right? It should apply on true or false. That's how it's supposed to be. But in Python, they consider other values as true as long as they are not the empty values. So you can use the or and the not on values that are not true or false. If the value that you're using is not empty value, so like it's not empty string or empty list or zero, then it's considered true. Okay, it can be a quick way to check whether a list is empty, for example. Okay, is this clear? I see confusion on some faces. Is this clear? Yeah. Now, for these strings, the operation that you probably are familiar with is the concatenation, right? So the plus sign, when you apply the plus sign on numeric values, it's an addition, right? When you apply the plus sign on string values, it's a concatenation. So in addition to that, there is the repetition as well. So the star, if you apply the star on numeric values, it's multiplication. But if you apply the star on string values, it's repetition. It's just multiple concatenation. Okay, so that might be new. It can be really convenient when you try to format your output. So let's say we have two strings. Okay, hello, and another string that we want to concatenate. So we can use the plus sign for that. Okay, so that's just the concatenation that we already know. Like now, what if I want to repeat that twice or repeat that 3 times or whatever number of times I want? Okay, so I can use the multiplication or the star for repetition. Let's say I want to repeat it twice. So it is like behind the scene, it is also concatenation, but just repeated two times. But here's the thing: when you use a star, it has the same operator precedence. So the star applies before the plus. So what will happen is that it will concatenate only the word world twice, and then would concatenate that with the word hello. So you see? Now, if you want to repeat the entire string, in order to avoid the operator precedence, what we do? Yeah, we use the parenthesis. So we want the plus to apply first and then the repetition to apply after. So let me also add a string space here. All right. So that can be really handy if you want to draw bars or shapes using strings. Okay, that can be really handy. All right. Now, these are the data types and these are the operations that apply on them. Now, we want to store these values somewhere so that we can access them later and we can accumulate applications and processes, right? So we need some sort of a data holder. So a data holder, there's two types of data holders. There is a variable, so a data holder that can change value, and there is a constant. And the constant is a data holder that the first keeps the first value forever and cannot change it. Okay. Now, how do we define variables here? There is something called or there are two categories of languages when it comes to the type, the data type of the variable. There are some languages that are weakly typed. Some languages are strongly typed. So what does it mean? Strongly typed, like Java, when you define the variable, you specify the data type of the variable, and that's the type it has to stick with for its entire life. So let's say you said int x, for example. So that's x is an integer. It can only hold integer or anything compatible with it. Okay. A weakly typed language like Python, the variable doesn't have a type. The variable is just a name. Okay. That name, you can use it to point or to hold any type. And you can change the type at any time. Okay. So let's say, for example, here, we want to have a variable x. So it's just without let or var, without any precedence. So you can say x equals 5. Okay. Now later on, I can print x, so I can read it. I can use x in operations, like I can apply mathematic operations. So let's say x plus 10. All right. Yes. So print x is a function that prints. In the interactive mode, yes. In the remember the ripple loop? So there is a printing that happens in the background. But if you put this in a script, it's not gonna print it unless you actually use a print. All right. So now, so far, x is an integer. We can apply calculations on it. Now later on, I can say x. I want to store a string in it. So ABC. Now, if you try to do that in Java, it wouldn't allow you. Okay. But here it does. There's no problem with that. So I can print it. I can read it. Now, if I try to say x plus 10, like I did before, now it gives me an error because x now holds a string and you cannot, now it doesn't know what to do. Are we dealing, is this a concatenation or is this an addition? Because you have two different types. Now in Java, there is conversion, automatic conversion that happens. That doesn't happen in Python. There are ways around it. But the point is that x is not an integer anymore. It's not a numeric value anymore. Okay, so now if I try to say x plus ABC, that's fine because we're just concatenating two strings. All right. Now, as we see, at least with strings, oftentimes we want to print integer like a message with a number, or like we want to mix some types. We can do that using the type conversion. It's not exactly type conversion like in the casting concept in Java. It's just you create an object of the new type. So here, for example, let's say we have a value, let's say Z has a string that we read from a user or read from a file that came as a string, but it is actually a numeric value. Okay, but it's a string. Okay, now if I want to add that string to a number, I can't. Okay, unless I change the type. Since I know it is a proper integer or a proper numeric value, I can call the constructor. We're going to talk about what does it mean, why this is a constructor. So this is a constructor of the class int. I'm just creating an integer version of the string value that I am. Okay. So that the result of this is the numeric representation of that string, which can be added to any number. No problem. Okay. Now we can convert between ints and floats because int and floats are compatible. So if you have an int like this, like the 5 here, if you convert it or create a float version of it, it would be, you just add the fraction, the decimal points and a 0. If you take a float value and create the integer point, it just truncate the fraction point.